6.4, the quadratic equations. Now, quadratic equations are something that come up quite often in the real world. Anytime you throw a ball or you shoot an arrow or you shoot a basketball, the path that follows is actually this thing that looks like this, right? Does anybody remember what that's called? A parabola. So the graph of a quadratic equation is a parabola. Therefore, you know, if we've got this science experiment, we've looked at where the position of this ball is that we've thrown, and then we want to work backwards and find an equation that like models that particular event happening, it's always going to be a quadratic equation. Okay? So anything that follows a path that looks like an arch can be modeled with a quadratic equation. So there are lots of places where this appears, so we do need to know how to work with this and how to solve these types of equations on a regular basis. So it's an important piece of information. Now this section is mostly about solving quadratic equations. We'll have a few application problems there towards the end. And we have methods, distinct methods for solving quadratic equations. The first one is factoring. We do a whole lot of that in Algebra 2. Remember the factoring where we take the trinomial and we turn it into two binomials? Okay, so we can factor it if the numbers are nice. Then we can also use something called the square root property. Square root property happens, and I can only use this if I have an x squared term but no x to the first power. Or if I set this up in a certain way, and I'll show you what I'm talking about. We didn't get to that. It's called completing the square. Utilizes this square root property. And that's where we actually kind of artificially set the situation up where I can make it into one of those deals where I don't have an x term anymore. It's just the x, it's got a square in it. It doesn't have an x to the first power sitting there looking at you. Okay? And then the last way that we talked about, or that you saw back in Algebra 2, was the quadratic formula. The quadratic formula is that the x values that are the solutions to this equation are equal to the opposite of b plus or minus the square root of b squared minus 4ac over 2a. So, just kind of an overview of the stuff that we're going to talk about. And then, of course, like I said, at the end, we're going to do some applications with some real-world stuff so you can see how you would actually use this and why it's even important to learn. Okay, so everybody got that page done? All right, so let's go back to factoring, which is objective 1 in this section. Go to checkpoint 1. So we've got 3x squared minus 9x equals 0. And then the other one they want us to do in checkpoint 1, 2x squared plus x equals 1. All right. So the idea behind factoring is if I can make this to where this is two things that are multiplied together, then I can set each factor equal to 0, and that'll give me all my solutions. So here, if I'm going to factor this, there's just two terms, and you always start out by looking to see is there a common factor I can take out. So I've got smaller things to work with. So what's the common factor here? 3 and x. So I've got 3x. Now when you factor something out, what you're doing is you're dividing it. You're doing the distributive property in reverse. So we pulled the 3x outside the parentheses. Now left inside the parentheses is whatever I would have to multiply 3x by to get 3x squared. Just a x and a minus 3. Because if I divide negative 9x by 3x, I get left with negative 3. And see, now I do have this as just two factors that are multiplied together. So I take each factor separately and set it equal to 0. So I get two distinct problems there at the end. And if I divide both sides here by 3, I get x is equal to 0, which is one solution. And here I need to add 3 to both sides, so x is equal to 3 is my second solution. Now in this question, part B, I'm not equal to 0. This rule, this idea about two things multiplying together and either one can be 0 to give me a product of 0 only happens if I'm equal to 0. So the first thing you have to do with every problem that you work with is to set it equal to 0. So in this case, what do I have to do to get 0 over there on the right-hand side? Move the 1, subtract the 1 from both sides, so I get 2x squared plus x minus 1 equals 0. Now the last time that we looked at this, I went ahead and reminded you about the bottoms-up method. Okay, it's just a little trick, but it does work for everything. So you can take this number, this coefficient in front of the x squared, and multiply it by the constant, and turn this into x squared plus x minus 2. Because 2 times 1 gives me 2. I just multiplied it together. Now I need two numbers that multiply together to give me negative 2, that add together to give me the positive 1. So x plus 2, x minus 1. Okay? But before you do anything else, after you get it factored out, the very next step is to take that 2 that you multiplied by and divide it back out. So there's, okay, so you divide it out of both factors. Okay? Now, this gives me x plus 1 times x minus 1/2 equals 0. And we talked last time about the fact that you can either make that 2x minus 1 or leave it like that. Because now all I'm going to do if I'm solving is I'm going to say x plus 1 is equal to 0 and x minus 1/2 is equal to 0. Right? And so x is equal to negative 1 and x is equal to 1/2. So there are my two solutions. Quick review. The next objective in the book is the square root property. Square root property allows us to solve just a specific kind of problem. So checkpoint 2. I'm on page 265 if you're keeping up with me. I got 3x squared minus 21 equals 0. And then it's got a part B. 5x squared plus 45 equals 0. And part C, x plus 5 squared equals 11. Okay? So, see, this is what I was talking about a while ago. If I have an x squared in there but no x term, then that allows me to do this like I used to do linear equations, which is pull all the numbers away from the x, put it on the other side, and then I can solve it. So my first step would be to add 21 to both sides. It's a 0 pair, so I've got 3x squared is equal to 21. Then we can divide by 3. So x squared is equal to 7. And so what? Right now. Here I'm just a positive 7. But the very next step, I've got to take the square root of both sides. When I take the square root of both sides, that's when I put my plus or minus. Right then. And this will be my answer because this cancels out and I'm left with just x equals a positive or negative square root of 7. Yes. Okay? Now on the next one, I'm going to start out by subtracting 45 from both sides. So I get 5x squared is equal to a negative 45. And then what do I need to do? Divide by 5. So x squared is equal to negative 9. Now I need to take the square root of both sides. And anytime I take the square root in order to solve something, I've got plus or minus. So this becomes x is equal to, now this time I can get rid of the square root symbol. Because the negative comes out as I. Negative comes out as I. And the 9 comes out as the square root of 9. 3. So I get positive and negative 3i. You're always going to bring it out as I. You're never going to leave a negative sign underneath the square root symbol. Okay? All right. Now, on this one, there's nothing to take over yet because everything that needs to be got the square on it's inside parentheses, right? So I've got to take the square root first on this particular problem. So I get plus or minus 11, square root of 11. Go ahead and take the square root right at the beginning on this one because there's nothing over there outside the square. Now this cancels out and I'm left with x plus 5 is equal to a plus or minus square root of 11. And then I can subtract 5 from both sides. So I get x is equal to negative 5 plus or minus the square root of 11. And you're finished with that problem. I did the negative 5. The 5 and the square root of 11 aren't like terms. They can't combine. All I can do is list them. So I stuck the negative 5 in front and then put my plus or minus the square root of 11. You'd have to divide. You'd have to divide by that. Yeah, it'd start looking kind of ugly, but that can happen. So, all right. Now, that last problem is what we're going to be doing with that part that we haven't done yet called completing the square. We're going to be changing what we have so that it looks like this, and then we'll solve it the same way. So let's look at the next objective called completing the square. We haven't done that yet. Now, before we get started on this technique, I need to show you where I'm coming from. We are trying to get this to where it's of the form x plus some number squared is equal to another number, okay? Now, for me to be able to get it in that form, then I have to remember that x plus a times x plus a is what x plus a squared is, right? And if I do full, then that gives me x squared. I've got an ax and an ax, so plus 2ax plus a squared. Everybody see that? If I full it, that's what I get, right? If a is a number, it'd be a little easier, I know, but I need you to look at the general form. Okay, so keep this in the back of your mind that I'm trying to utilize this idea right here. So, checkpoint 3. We've got x squared plus 4x minus 1 equals 0. Now, the reason we complete the square is because this is one that's not going to factor. You know, I can't even do my little trick of pulling the number over in front because then it'd still be just 1. There's no two things that multiply together to give me 1 that add together to give me 4, right? It's not going to factor. But with completing the square, we can always make it factor nicely. But this is the trick. I need this to be this form, where this is 2 times some number times x. And then I need it added to that, the number squared. So to get that to happen, I'm going to write x squared plus 4x plus some number. I don't know yet what that number is going to be, but I'm going to add something in there. And this negative 1, I'm going to actually add it to both sides, so I got it out of the way so I don't have to think about that. Everybody hear what I just said? The number part, take to the other side so that we don't have to deal with it right now. We'll move it again in a little bit. Okay? Now, if I added a number here, what's got to happen over here? We've got to add that same number, right? Now, I got to figure out what number works. And this is how you figure it out. This is 2 times the number, right? That's what my formula says. It's always going to be 2 times the number. So I'm going to go to this coefficient of x, which is 4, and I'm going to divide it by 2. That'll tell me what my number is. I divide it by 2 every time. Okay, so whatever the coefficient of x is, I'm going to divide it by 2. So my a in this problem is 2. Now, did I add a here, though? What needs to be added? What is this right here? What is it? A squared. So I don't need to add a, I need to add a squared. So you're going to take what you get for a and square it. 4 is what I need to add. So I need to add a 4 here and a 4 here. Okay? Now, I've got this set up to where it's x squared plus 2 times x plus 2 squared, right? So that means that I could rewrite it as a plus x plus, not 4, what was a? 2. So this whole side becomes x plus 2 squared. If you don't believe me, write x plus 2 times x plus 2 and multiply it out. We fixed it. It's going to do that every time. Every time you do this. Okay? And that's equal to 5. Now do you see the similarity between part C of the last checkpoint? Because now we've got it in that form that we can always do the square root property on. What are we going to do here? Take the square root of both sides. So I'm going to take the square root of x plus 2 squared and plus or minus the square root of 5. And then this all cancels out, and I'm left with just x plus 2 is equal to a positive negative square root of 5. Supposed to bring a pillow? No. And so I need to do what? Minus 2 from both sides. So x is equal to a negative 2 plus or minus the square root of 5. Okay? We good? We'll do another one. Checkpoint 4. This one sets it up a little bit different. It says find all the zeros of f of x is equal to 2x squared plus 3x minus 4. Okay? So find all the zeros. What does that mean to us? Set it equal to 0. Thank you so very much. We're going to take that equation and set it equal to 0, and that's exactly what we're supposed to do. So we've got 2x squared plus 3x minus 4 equals 0. Now this one is a little bit uglier to complete the square with it. Okay? Because of this 2 sitting in front of here. I would never pick completing the square to do this problem. Anytime you have a coefficient of x squared, I would do the quadratic formula if you can't factor it. Okay? But we'll go ahead and do completing the square, give y'all some practice on this. Or no. Do you want to see it or not? Not really? Not if I say to you it's not a good idea? All right. So it's on one of the problems that you have to do. All right, so the first thing when I complete the square is I move the constant to the other side. So I'm left with 2x squared plus 3x equals 4. Now, I don't mind fractions. So what I would do is I would go ahead and just divide the 2 out. Okay? If I divide that by 2, divide that by 2, and divide that by 2, I'm good, right? So that leaves me x squared plus 3 over 2x equals 2. Now, the reason I say I'm good with fractions is because now when I do this over to the side, I got 3x and I need to divide it by 2. But is that a problem? What's the same thing as dividing by 2? Multiplying by 1/2. So I'm going to multiply it by 1/2 because that's the exact same thing as dividing by 2. And if I already started with the fraction, I definitely don't want to make it a complex fraction. You can put it in your calculator and do 3 divided by 2 divided by 2 and then change it back to a fraction. And you're going to get this same 3 over 4 that I got. Okay, so don't worry about it if you know you're thinking I wouldn't be able to do that. Okay, this is your A. Once you've done your divide by 2 or multiply by 1/2, you found A. Okay, so this is going to turn into x plus 3/4 squared. If I add what? I got to take 3/4 and square it. So that's 9 over 16. Because remember, if I square a fraction, I just square the top and I square the bottom. Yes? Okay, so if I add 9 over 16 up here, then I've got to add 9 over 16 here. All right, because what I do to one side, I got to do the other. So that's going to be equal to 2 and 9/16. So if you just want it as one fraction, that's 2 over 1, which is the same thing as 32 over 16, isn't it? Because 2 times 16 is 32. Right? 2 over 1, but I want the 2 over 1 to be written as a 16th. So I've got 32 over 16 plus 9 over 16, which gives me 41 over 16. Okay, we good? Again, you could have put that in your calculator and got that same number. You just have to tell it to change it to a fraction when you get finished. Do 2 plus 9 divided by 16, then hit math and change the fraction, and it'll give you the same number. Okay? Now, I got to take the square root of both sides. So I get x plus 3 over 4 is equal to a positive or negative square root of 41 over 16. Now, just like when I did the square root of a product, and I could take each part, I can do the square root of a quotient too. So I can rewrite this as plus or minus the square root of 41 over the square root of 16. Are y'all good with that? Y'all understand what I'm doing there? As long as I'm not adding or subtracting, I can take the square root of each part. And so I've got x is plus 3 over 4 is equal to a positive or negative square root of 41 over, what's the square root of 16? 4. And I subtract 3 over 4 from both sides. So x is equal to a negative 3 plus or minus the square root of 41 over 4. Right, because they got the same denominator, so I can just list the numerators and put it over that denominator once. Again, don't let the fractions bog you down. It's just the same process. Again, that's why I say, if you get to decide what method you use, I would never use completing the square on something that's got a coefficient in front of x squared. Completing the square is nice, and it actually is very quick, as long as the coefficient in front of the x squared term is 1. Okay? So, if it were me, then, I'm sorry, what? Did you need this? Okay. If it were me, my objective 4 is by using the quadratic formula. That's the way I would have done that problem. Because on the quadratic formula, basically all you do is you have to remember where A, B, and C come from. Quadratic formula is based on the equation in standard form. So it's ax squared plus bx plus c equals 0. So a is the coefficient of the x squared term, b is the coefficient of the x term, and c is the constant. But this only works if what? I have the equation set equal to 0. Okay? That's the big part of it. Okay, so check point 5. We got 2x squared plus 2x minus 1 equals 0, and we want to solve this. Now, this is one of the ones that I would say don't do it by completing the square. Why? That 2 in front of the x squared. Much better to use the quadratic formula. So a is equal to 2, b is equal to 2, and c is equal to negative 1. And it'd be worth your time to go ahead and write that down at the beginning of all these problems. And I can just pull it out of there because I was already set equal to 0. So x is equal to the opposite of b, negative 2, plus or minus square root of 2 squared minus 4 times a, which is 2, times c, which is negative 1. You did do this in Algebra 2. Yep. Okay. Now, we talked last time about, I want you in here, when you do this, don't try to stick this all in at one time. I want you to simplify what's underneath the radical first. So we're going to write x equals negative 2 plus or minus the square root. 2 squared is 4 plus 8, so I got 12 over 4. Okay? Without doing the square root, I just want you to do what's underneath the square root and simplify all of that stuff first. Now, remember what we talked about before about these square roots? You look to see if there's a perfect square hidden inside there. And 12 is 4 times 3, right? So I've got x is equal to negative 2 plus or minus. If that's the square root of 4 times the square root of 3, tell me how to rewrite it. What's the square root of 4? 2 times the square root of 3 over 4. Now, what I hope you notice is that you've got 3 terms here, and they all have a common factor. What is it? 2. I can factor 2 out of everything. So that becomes a 1, that becomes a 1, and that becomes a 2. Now, that only works if you can do it out of all of them. If you just could have done it out of the top and the bottom once, don't do it. Okay, only if you can mark something out of every single one of the terms. So I've got negative 1 plus or minus the square root of 3 over 2 is my final answer. Much easier than completing the square with all those fractions, right? I mean, anytime that I see this business going on right here with this 4 and this 2, I start thinking, oh, wait a minute, I might be able to reduce this so that it's got a 2 in it. So I start looking. That's my, signal. Then if it does, great. If it doesn't, fine. Just leave it like this. Okay? The big thing is going to be able to try to find your answer on that multiple choice final. So that's the big thing, is you got to get to where you can, if you come up with this when you work the problem, you got to recognize that it goes with this somehow or another. So you could kind of start looking and seeing, well, what did they do? Oh, it looks like they reduced the 2 out of these 2, so maybe there was a square root of 4 in there. Okay, you might have to work backwards a little bit. Okay? All right, now, Objective 5 in this section talks about the thing called the discriminant. The discriminant is this part of the quadratic equation. That stuff underneath the square root sign. Okay? If this number, when you simplify it all out, is a positive number, the way I write a positive number is I say it's greater than 0, right? If it's greater than 0, then you're taking the square root of a positive number. That's just a number, right? Might not be a pretty number. It might be something like square root of 11. I can't get rid of the square root symbol, but that's just a positive number. Okay? If this happens, then you get 2 real, they call them zeros or roots in this book. They actually call them intercepts. All right, so we get 2 real solutions, which happen to be 2x intercepts, right? That's where we get zeros, where I cross the x-axis. There's 2 of them. If the discriminant is exactly equal to 0, so if I take the square root of 0, I just get 0. And if I add or subtract 0, does it change anything? No. So here, I just get 1 real solution. Or 1 x intercept. Okay? And if the discriminant is a negative number, oh, what happens if we got the square root of a negative number? It's an imaginary number, right? So I get 2 complex solutions. And that, how many x-intercepts is that? No x-intercepts. That's exactly right. An imaginary solution does not cross the x-axis. Okay? So if you look at the discriminant, it'll tell you what kind of roots you have. And there's some of the problems on there which says, tell me the nature of the solutions. So once the nature of the solutions is wanting to know, are there 2 real solutions? Is it 1 real solution, or is it 2 imaginary solutions, or 2 complex solutions? Okay? Any questions about that? Objective 6 gives you a whole table on page 272 if you want to look at it. And it gives you some ideas of which method is actually the most efficient. So you can read that over yourself without my help. 272. On page 272 is a table to help you determine the best method for solving the quadratic equation. And then, like I say, at the end of the section are just the application problems where you're going to have a quadratic equation that comes up in this word problem. And you'll just do this process that we've been talking about. All right. So all that's in that section.